The passage of a black hole or a similar influence object through the solar system in the not-too-distant past leaves more and more evidence. The base of arguments is increasing. Practically all known details and uncertainties in the positions of planets, the tilt of their rotation axes, the strange gap in the Kuiper belt, orbital bombardments of planets, the appearance of new moons and the disappearance of entire planets, the appearance of the asteroid belt, and the impossible mass of Jupiter and Saturn all fit into the assumed scheme of events development. And it seems that in the past 3 episodes, we have analyzed all possible versions and evidence. However, it turns out this is still far from everything. Hello, you are on the Epoch of Distrust channel with Mikhail Kalmykov. This is the final film about the culprit of the shift of all planets in the solar system. We will find the approximate positions of the planets at the moment of the black hole passage, the position of the hole itself, even its course, and at the end of the film, we will try to find evidence of this in the printed sources of past centuries. And yes, I repeat once again that all my statements are nothing more than assumptions, a hypothesis. And although it answers many questions, it raises no fewer new ones. Well, for example, all my statements I make based purely on the hypothetical assumption that the mass of the black hole was equal to the mass of the sun. I have no evidence that this is exactly the case. The only reason I took this mass as a basis is that it is most likely its minimum possible mass. Practically on the border with a neutron star? In any case, astronomers already have as many as 3 contenders for the role of small black holes. This is the object XTE J165500 with a mass from 4 to 5 solar. Object IGR J17091362, for its mass is estimated to be approximately 3 solar masses. And object JRO J042232, whose mass is estimated at 2 solar. Nevertheless, these are black holes that we observe. That is, they are in an active phase and are eating neighboring stars. In fact, that's why we see them. But physics allows for the existence of holes with less mass, about 1 solar mass. It's much harder to notice them because they mostly don't manifest themselves. But that doesn't mean they don't exist. For the most part, it doesn't really matter to us. Whether it was a hole or a neutron star, the effect of its passage near us would generally be the same. But everything has its time. Let's start with the theoretical part. Many lay people have been scared off by our science popularizers with the idea that a black hole will inevitably suck in everything that passes near it. And it's a universal evil from which it's impossible to escape. It's precisely this psychological barrier that prevents many from even considering such a possibility in their minds. Some sort of primal fear and panic coming from somewhere in the dark depths of the subconscious. In reality, things are a bit different. In the universe, the decisive role is played by the mass of an object and its speed, and if hypothetically we replace our sun with a black hole of the same mass, then almost nothing will change. The planets would also continue to revolve around the new black light. Jupiter will remain a gas giant, just like Saturn. The moon will keep revolving around the Earth. Well, unless Venus dries up, the Earth will freeze, simply left without sunlight. But one of Jupiter's moons, Io, wouldn't notice the difference at all. Its heat is not due to the sun's rays, but due to tidal forces caused by its proximity to Jupiter. Mercury, too, might not be affected as much since it is influenced by the tidal forces of the black hole itself. We could go on about the consequences of such a replacement, but we'll save that for another time. The main thing is, if the mass of the black hole is the same as the mass of the sun, then the orbits of the planets will not change at all. The exact passage of a black hole through the solar system does not necessarily suck in all the planets in the sun. No, of course, colossal damage will be inflicted. But for the most part, it will be caused by induced chaos, not total consumption. Of course, small objects in the Kuiper Belt are doomed for the most part. But the large planets could very well hold their own. Yes, and the sun will fight for its honor, having quite a comparable gravity. So those planets that are located as close as possible to the sun get the highest chance of survival. These are Venus and Earth. But the further away, the weaker the influence of the sun and the stronger the influence of the whole. Therefore, to understand what happened, and ideally its exact position in the solar system, where it is, and ideally its exact position in the solar system, where it went, under what angle. Yes, we've seen in past episodes the failure in the Kuiper Belt, but we still don't know, for example, whether it's an entrance or an exit. Let's figure it out. Our civilization has reached such a level of development that it has learned to send spacecraft to the very edge of the solar system and even further. However, this is not a simple matter. Our entire system, right down to its edges, is in the zone of influence of the sun's gravity, which is quite logical. That is, any flying space apparatus, once launched from Earth, after burning fuel in the booster block, began to experience the braking action of solar gravity. The speed initially gained by the apparatus from this point continuously decayed and decreased. Well, how else? There is no more fuel, or there is very little of it, the engines are weak, and the influence of solar gravity is not going anywhere. Nevertheless, we know that scientists somehow managed to accelerate their devices further, despite almost empty fuel tanks. How do they manage to do this? They use a secret in the following. The device passes very close to any planet, and under it in the following. The device passes very close to any planet, and under the influence of its gravitational force, it gains speed. But after the device passes the point of maximum proximity to the planet, it begins to move away from it. And then all the accumulated speed under the influence of the same force begins to fall, and it falls to the original value, according to the law of conservation of energy. So what is the focus then? And it's all about the direction of the object's movement. If the device moved parallel to the planet, then the time spent in its gravity zone, both during the catching part of the flight and during the moving away, would have been the same. Accordingly, after the device left the planet's influence zone, the speed would have remained the same. But the whole point is that the route is designed in such a way that the exit time from the gravitational ring is less than the entry time. As a result, the speed increases over time. Scientists have long compiled tables and schemes of entry and exit from the gravitational rings of planets, as well as calculated the maximum possible speed increase that one or another planet can give. For example, Mercury can give an increase of 3 kilometers per second, Venus 7 kilometers per second, and Jupiter can add as much as 42 kilometers per second. This is the clever way our space devices gain speed. But such a maneuver is not only subject to our civilization and our technologies. In principle, any space object can do this. The key is to properly align with the situation, and they match quite regularly. It's not such a rarity in space. I told this to give an understanding of how the interaction of two objects in the universe will occur with each other. For a body to leave the sun's sphere of influence, it must have a third cosmic velocity. That is, it must move away from the sun faster than 47 kilometers per second. Our system moves through the galaxy at a speed of 20 to 25 kilometers per second. And this is not the highest speed. A black hole, for example, can move even faster, up to 1,000 kilometers per second and even faster. However, even if it moved at a speed of only 300 kilometers per second, the difference in speeds would still be more than necessary. And this tells us that in a similar scale of catastrophe, it is most likely not going to happen again. In any case, in the near future. Well then, at least that's something good. But what does a gravitational maneuver have to do with it? I'll show you now. The laws of physics in the universe act the same on both small and supermassive bodies. Two objects with high gravity, moving at tremendous speeds on intersecting courses, inevitably exert a similar influence on each other. And our sun, along with it, and the entire solar system, encountering a black hole or just another star on its way, will perform a gravitational maneuver relative to each other in exactly the same way. The direction of motion changes sharply at the point of maximum approach. And depending on the angle at which they meet, the angle of subsequent motion changes, as well as the angle of the general plane of the system's ecliptic. Remember, in the first part, I showed how such maneuvers change the planes of the planet's ecliptics. They change the plane of their ecliptic, the rotation around the sun, but at the same time, like any normal gyroscope, they maintain, if possible, of course, their axis of rotation relative to the old plane. Thus, it seems to us that the Earth or any other planet has tilted its axis. Although in reality the axis remained the same, the inclination of the ecliptic plane changed. So the same thing happens with the entire solar system, but on a much larger scale. The entire solar system has sharply changed its course and direction of movement, while preserving as far as possible the old flatness. But judge for yourselves. As I've already told you in every past episode, the solar system was formed from a protoplanetary disk, which ensured a general flatness of the ecliptic for all planets. But the original positioning should have been synchronized with the flatness of the galactic ecliptic. The original positioning should have been synchronized with the flatness of the galactic ecliptic. Nevertheless, some unknown force turned it as much as 60 degrees and directed the path of our solar system not along the disk of the galaxy, but at a large angle. And at this moment, our system is heading towards the exit from the sleeve of the galaxy. Once upon a time, long ago in my childhood, when the Union of Soviet Socialist Republics still existed and I was a green boy, I often went to the Moscow Planetarium. I would get lost there for hours, sometimes even with Zaitsev, attending one session after another in a row. I remember that no more than 4 sessions were held in a day, and I attended all of them. Like a spellbound, I watched and listened to everything that the lecturer told and showed. And returning home late at night, I looked at the same stars in the sky. My favorites were then the Pleiades. Yes, back then in Moscow, you could still see the stars in the sky with the naked eye. So, something from those lectures imprinted in my memory forever. In particular, one of them explained that our solar system moves around the center of the galaxy in a wave-like manner. Why exactly this happens was not explained, but emphasis was placed on the fact that our sun is a solitary star. But every time the solar system passes the peak of the wave and changes course to the reverse, a process of mountain formation, global shifts, and stress for the planets occurs. And the period between these peaks is approximately 60 million years. Somewhere, probably, you can find that very lecture right now. More than 35 years have passed since then. The Union of Soviet Socialist Republics no longer exists. The Moscow Planetarium is over 35 years old. The Union of Soviet Socialist Republics no longer exists. The Moscow Planetarium is, or not. But in any case, now I understand what astronomers were trying to figure out, why our sun doesn't move the way it should. And the wave motion version was just trying to explain the sharp changes in poles, axes, ecliptic disks, and global terrestrial tremors, particularly in the lithosphere. Now let's turn to history. Let's see if there is evidence of a sharp change in direction in history. Let's see if there is evidence of a sharp change in direction. So, 1,870 years. Remember, what volume of astronomical events does this time signify? If not, then check out my previous videos, you won't regret it. Especially the 7th part of the series, Unnoticed Apocalypse. Well, we are opening the World Illustration Magazine, Volume 3, for the year 1870. And on page 102, we read the following. It has been known for 20-30 years that some fixed stars change the brightness of their light from time to time. Recently, it has been confirmed that some of them also change their color. If we believe Ptolemy, then Sirius has significantly changed its color over the last 2 millennia. Ptolemy directly relates Sirius to the number of red stars. Now Sirius is completely white. This is an interesting note. There is still a lot of interesting stuff about comets and about photographing stars, and I won't drag out the chronometer. We are only interested in the fact that Sirius has changed its color from red to white. Just remember this fact. That's not all. A year later, in the same journal, in the 5th volume, on page 349, another note about Sirius comes out. It also mentions that Sirius used to be red, but now it's silver-white, and they seem to acknowledge this fact. Here's how they explain this phenomenon and acknowledge this fact. Here's how modern astronomy explains this phenomenon. Sirius is a binary star, one of which has become a red giant. And it was like that for almost 1 million years. But over the last few thousand years, the red envelope has disappeared somewhere. And we see the light of only one star, Sirius A, a dazzling blue-white. Stop. But the notes say that it was first just white, a year later silver-white, and now almost blue. I think those who watch my videos have already guessed what I'm getting at. Well, I recommend the rest to watch the video, The Universe is Not Expanding, or Who Interfered with the Ether. So, in my opinion, a sharp change is not a change in the direction of movement. When Sirius moved away from us, it was a change in the direction of movement. When Sirius was moving away from us, it was red due to the Doppler effect, causing a red shift in all receding stars. But then it suddenly changed direction and started approaching us at a tremendous speed. Therefore, due to the same Doppler effect, its visible color changed from red to bright blue. Undoubtedly, skeptics will say that there was no sharp change in color. The whole process took more than 2,000 years. And I disagree because this is a manipulation of facts. Look, our consciousness perceives the entire given time segment as time, completely wasted on some transformation. However, Ptolemy, to whom the article refers, lived approximately in the 30th year of our era. The color of Sirius was red then. But already the Chinese astronomer Xintian says that when the planet Taibo, that is Venus of white color, it is comparable to the star Lan, that is Sirius. And Xintian lived from the 30th to the 86th year of our era. In other words, he was born right after Ptolemy. And that means the color change of Sirius occurred over a maximum of 50 years. So what? Will the star shed its shell? What's so surprising about that? What's surprising is that it's a binary star. And while one of the stars was a red giant, we saw it as the brightest star in the red color sky. And we see it as the brightest star, but already the second one in the pair, the one that is Sirius A. That is, the brightness of the star remained, but the other one. By the way, where was all this time the second one was hiding in another one? By the way, where was the second one all this time? Was she hiding in the shadow of a friend? But they are equal in brightness, so what do you believe? Into this nonsense, or that the star simply changed its course? And yes, right now it's moving towards us at a speed of about 7 to 8 kilometers per second. One could say that historians are lying, that Ptolemy did not, that there was no Simtian, or that they were in the 15th century and the like. And you know, I might even agree. But in this case, it still almost changes nothing. We're talking about something else. And whether the story is stretched or not, it doesn't bother us at all. Meanwhile, the article in the Universal Illustration magazine does not end with this. Next we read, and the unknown consequence of its remoteness. The distance to Sirius is so great that the consequences of its remoteness are unknown. The distance to Sirius is so great that the light from this star reaches Earth over the course of 22 years. In addition, it is noted that Sirius has significantly shifted its position over the historical period and has moved from its previous position almost the length of the moon's diameter. For us, it is immediate and contrary to history. If such a so-called historical period contradicts history, if the so-called historical period occupies 2,000 years or so, then a similar shift of stars for 1,000 years or so, then a similar shift of stars in length, and the actual dates of life of the same Ptolemy relate to the 15th century, then a similar shift, softly speaking, raises questions. Moving at such a speed across the sky is, to put it mildly, abnormal. But the main nuance lies elsewhere. According to the author of the note, it's 22 light years to Sirius. That's 1,870 years. Now Google what the distance to Sirius is now. 8 whole and 6/10 light years. That is, Sirius has shortened the distance between us by as much as 30 light years in just 150 Earth years. Of course, I tried to find a message on the internet that at the end of the 19th century, the distance to Sirius was calculated incorrectly. By the way, this is the first star to which the distance was calculated. However, I found no mention of this error. Perhaps you will be able to do this. I'll wait in the comments and will appreciate it. Well, in the dry residue, we have the following. First, traces left in the solar system from the passage of a massive object nearby. Second, changes in the inclinations of the ecliptics of almost all planets and even the Sun. What about the Sun? The entire solar system is tilted at 60 degrees relative to the plane of the galaxy. Third, a sharp change in the course of the solar system, which, according to the assertions of the astronomers themselves, inevitably had to start catastrophic processes. Fourth, a sharp change in the color of Sirius, which again tells us about the change in the direction of mutual movement. Fifth, again it tells us about the change in the direction of mutual movement. Fifth, if it moves towards us so quickly, then someone is deliberately pushing the data. Well, at the very beginning of the video, I promised that we would try to calculate the path of a black hole through the solar system. Well then, let's go! According to the hypothesis, the tilt angle of the planet corresponds to the influence exerted on it by the black hole, and consequently, the distance at which the planet was at that moment. We know that the force of the gravitational field decreases from the mass in accordance with the law of inverse squares, and conversely increases proportionally to the decrease in distance. However, now I do not have the task to tell and prove everything in detail. I will only show the principle by which one can determine. Therefore, for simplicity, let's assume that this will be a straight line increasing on the graph. Let's represent the scheme directly, that it will be a straight line increasing on the graph. directly to and starting from the encounter of the sun's gravity and ending with the planet's own gravity. Let's assume for a second that our black hole is a spherical horse in a vacuum. Now let's build a model of the solar system to scale with the correct, that is, current ratios of orbits and, accordingly, distances between them. Now the scale. Each division on the scale represents 1 degree of deviation from the axis. 90 degrees is equal to the center of the black hole, and the further extension of the scale to 180 degrees gives a negative deviation from the axis. Let's spread our scale in the form of a disk on the solar system. Now we scale down the division according to the hypothesis. For adjustment, let's take Jupiter and Earth. We'll place Jupiter on the far end of the solar system, where it should deviate by 3 degrees, that is, at 3 divisions. We'll place Earth opposite and scale it down, that is, at 3 divisions. We'll place Earth opposite and scale the scale, and degrees, that's it, the adjustment is over. And here's your first revelation. Mars automatically took a position of 25 degrees with a small. That is, it practically took the exact inclination that it has now. 25 whole and 19/100ths of a degree. The scheme works. And that means we can rely on it and place Saturn there, and 300 degrees crosses its orbit. And wonder of wonders, such 300ths of a degree crosses its orbit. Miraculously, such a place exists. And in the meantime, we have obtained the location of Saturn and also Uranus. Now we know not only the place where Uranus's hole is also located. Now we know not only the place where the hole went through the solar system, but also the approximate angle of its entry. Judging by everything, it passed at an angle of no less than 60 degrees. Its route passed between the orbits of Uranus and the inner boundary of the Kuiper belt. Hence the dip in the belt. The scheme even allows to determine the distance at which Uranus was from the hole. That's about 2 whole and 2/10 astronomical units. That is approximately 330 million kilometers. Thus, we not only calculated the possible trajectory of the hole, but also got a graphical key that will allow us to indicate the date of the event quite accurately. All we need to do is rewind time on the simulator and find that moment in history and these places were occupied. In this series of videos, I only express the places were occupied. In this series of videos, I only expressed one hypothesis explaining the events that occurred. But there are others. However, they all have one common feature. In each of them, our solar system either intersects with a supermassive gravitational object. Now, I've taken the smallest black hole for consideration out of all possible ones. However, there is another variant with a normal black hole with a mass of tens or even hundreds of suns. In this case, its gravitational field will extend far beyond our solar system to the nearest stars. In this case, the mystery of the strange wave-like movement of the solar system around the center of the galaxy will be solved. We are simply part of a star cluster, and just like the other stars closest to us, such as Sirius or Alpha Centauri, we revolve around a single center of mass of a large black hole, thus forming a star system. Or we just pass not far from it, from a massive black hole, thus causing chaos in all our solar systems. And most importantly, it answers the question that has been tormenting astronomers for 80 years, the so-called Fermi paradox. In essence, it sounds like this. If there are supposed to be hundreds of thousands of civilizations in the universe, then where are they all? And the answer is simple. All the nearest star systems were also swept by the passage of this supermassive object. And the catastrophe that happened in ours, with a high degree of probability, happened to them almost simultaneously with us. So if there were civilizations, they are now sitting in bunkers or rebuilding their civilizations from scratch, just like us. if they survived at all. But that's a topic for other videos. Subtitles created by